We are going to prepare anthranilic acid using the Hofmann rearrangement of phthalimide using sodium hypochlorite bleach. There are a few published procedures, but they are not always consistently repeatable. This method is the one we've tweaked and used consistently. First, dissolve 18 grams of sodium hydroxide in 80 ml of cold water and with a few ice cubes added. To make up to 100 ml, stir and then chill the solution. Weigh out 30 grams of phthalimide. Take the chilled sodium hydroxide solution. We've put a thermometer in here so you can see the temperature changes that will occur. Be sure to use a beaker large enough to hold 500 to 600 ml of liquid. With stirring, and the temperature at around 10 degrees C, add the phthalimide powder to the sodium hydroxide. This will dissolve over a few minutes, and add an extra 50 ml of water if you need to in order to obtain a clear solution. The temperature will rise slightly to around 20 degrees. Take the resulting solution and chill back down to 10 degrees over about 20 minutes. We've now created a solution of sodium phthalimide. This will hydrolyze, so we need to use it quickly. Add to this a chilled solution of sodium hypochlorite bleach. We are using an 8.25% concentration and therefore need to use 190 ml, giving us the molar equivalent to the phthalimide. Stir this for 15 minutes, and you will notice a slow temperature increase up to between 35 and 40 degrees C. This is the formation of the isocyanate intermediate. You may see that the liquid is a very faint yellow color. Heat to 75 degrees C. Then allow the solution to cool and chill down. The temperature increase makes sure that all the unstable isocyanate rearranges to form our anthranilic acid product in the form of sodium anthranilate. Take 40 ml of the chilled product and reserve separately. This is in case we accidentally neutralize too far in. The next step. The pH of the solution is at this stage strongly alkaline. We now need to get it to exactly neutral by carefully adding concentrated hydrochloric acid. As you add the acid, you'll see CO2 given off, and a precipitate forming and redissolving. Stir the solution well. You'll see the color change to a yellow-orange. Around 20 to 30 ml of acid is required for complete neutralization, but be very careful and try not to overshoot. We're nearly there. And now slightly over, so add in the reserved 40 ml, and add acid drop-wise, testing carefully until the solution is neutral at pH 7. The neutralized solution is a yellow color, perhaps very slightly alkaline, but close enough. Now we add a weak acid, glacial acetic acid, to the solution in order to precipitate the anthranilic acid. Add the acid very slowly and stir vigorously as the mixture may foam. I've transferred the solution to a larger beaker to avoid any risk of this. Keep adding and stirring, and anthranilic acid will precipitate. This takes around 30 ml of acid to complete. The residual solution is now a dark brown color. Vacuum filter the product and keep it on the pump for at least 30 minutes to get as much water out as possible. Don't get too excited because the precipitate is very light. Unfortunately, a large volume has a small weight. After washing with 100 ml of cold water, refiltering and then drying in a warm oven to constant weight, here's our crude product. We obtained 12.4 grams of anthranilic acid. This is a 44% yield from the starting material, which is not great, but the product is fairly clean and pure. We'll continue to refine the process, as we have obtained up to 60% in the past, but it's not clear exactly where the challenge lies. The product can also be recrystallized from boiling water. Make sure the water is over 95 degrees C, as this makes a big difference to the solubility. You obtain crystals, which are a slightly darker color, which look like this when dried. Anthranilic acid is a versatile and fun starting point to benzene, anti-inflammatory drugs, dyes, and quinazolinone heterocycles.